So next is the MREs. We know that 209.4 and mole, we calculate mole. We have mole is 0.380 and mole ratio by dividing the smaller mole to all molar quantities. So we get 1 is to 3 mole ratio. So it means water mole is 3. Define stereoisomers. Molecule with the same structural and molecular formula, but arrangement of atoms in space is different. Uh, Next question is explain why the conversion of ethane to butene can be described as addition reaction. In addition reaction, only one product is formed, so that's why it is known as an addition reaction. So these are the two examples of the two stereoisomers of butene. This is trans-butene and this is cis-butene, because this is represented with CH3, and this is H is over here, this is CH3 and this is H. So CH3, same molecules on same side, so that's why this is cis, and this is like CH3 over here, CH3 over here, and H over here, H over here. So CH3 on opposite sides, two different molecules on the same side, so that's why it is trans isomers. Next question is chlorine is one of the element in group 17 of the periodic table. Describe the color of the group 17 element chlorine to iodine at room temperature and pressure. Chlorine is yellow green, bromine is orange brown, iodine is silver gray. Describe the relative reactivity of the element chlorine to iodine as oxidizing agents. We know that oxidizing strength of group 17 is decreased down the group, while reducing strength of group 17 is increased down the group. So oxidizing strength is decreased from chlorine to iodine. State what is observed when chlorine reacts with the hydrogen. So hydrogen react with chlorine to form hydrogen chloride. Chlorine color is green yellow, so yellow green, so yellow green is disappeared while HCl is formed. Explain why the thermal stability of the hydrogen halide decreases down the group. Thermal stability links with the bond length, and we know that the um, bond length is increased down the group due to increasing the number of shells. So bond length is inversely proportional to bond energy. So bond energy is energy required to uh, break the bonds between hydrogen and halides. So as hydrogen halide bond length is increased, so bond strength is decreased, hence, and less energy is required to break the bond. So bond length is, so we can say that bond length is inversely proportional to the bond energy. If bond length is more, less bond energy is required. If bond length is shorter, then more bond energy is required. So thermal stability of the hydrogen halide decreases down the group. So the halogenoalkane CH3CH2Cl forms when chlorine reacts with C2H6 by a free radical substitution mechanism. Define the free radical. It is a species with one or more unpaired electrons. State the essential condition for chlorine to react with C2H6 at room temperature. Ultraviolet rays are sunlight. Write two equations to show the propagation steps in this reaction. C2H6, we know that in propagation steps on reactant side, one is the normal molecule and other is the free radical. Chlorine is free radical, becomes free radical in the first reaction, while alkane is normal molecule. So on the product side, alkane will become the free radical by releasing one hydrogen atom, and HCl is formed. And in the second step, alkyl become the free radical while chlorine is normal molecule. So these are the two steps of the propagation reaction. CHCl3 is another halogenalkane forms when propanone reacts with NaClO. NaClO is made from chlorine in a disproportionation reaction. Identify reagent and conditions that can be used to convert chlorine to NaClO. So we know that NaClO is formed while CH3, this is the chlorine compounds. So when any chlorine compounds react with sodium hydroxide, there are two types of reaction uh, condition. One is the cold sodium hydroxide, another is hot sodium hydroxide. In cold sodium hydroxide, NaClO is formed, while in hot sodium hydroxide, NaClO3 is formed. So in this reaction, NaClO is formed, so the condition is cold sodium hydroxide. Define disproportionation reaction. Disproportionation reaction is a reaction in which same species is both oxidized and reduced. Write numbers in the boxes to balance the equation showing the reaction of propanol with NaCl. 3 with NaClO because uh, 3 first balance the chlorine. So when we balance chlorine, so 3 over here and 1 over here, 1 over here and 2 over here, because on this side, reactant side, 3 sodium are there, while on product side 2. So place 2 uh, in front of sodium hydroxide and to balance the sodium element. Aqueous AgNO3 dissolves in ethanol, reacts with an aqueous solution of CHCl3. State what is observed in this reaction, explain your answer. White precipitates of AgCl is formed when CHCl3 react with AgNO3 because CHCl3 is hydrolyzed when it dissolves in water to form chloride ions, and chloride ions react with silver ions to form silver chloride. Because AgNO3 is aqueous, like Ag positive plus Cl negative to form AgCl precipitate. So this is the reaction. The group 14 elements show a charge from non-metallic to metallic character down the group. Table 3.1 shows some properties of two group 14 elements. Uh, Carbon and tin in their standard states. The table is incomplete. Electrical conductivity of carbon is good because it has free moving electrons. Tin is type of bonding in graphite is covalent, and type of structure is giant macromolecule. So identify the lattice structure shown by the graphite giant molecular. Strain wise, tin has good conductor electrical conductivity as its delocalized electrons are free to move, because in metallic lattice there are free electron delocalized there are free delocalized valence shell electrons which are free to move. So all metals conduct electricity due to free delocalized valence electron. Carbon is found in magnetic in an organic compound such as carbonates. Write an equation for the reaction of magnesium carbonate with dilute HCl. This is very simple reaction, because magnesium, any carbonate when react with HCl, salt, water and carbon dioxide formed. So in this reaction, magnesium chloride plus water plus carbon dioxide is formed. To balance this reaction, place 2 over here. Describe the thermal stability of the carbonates down the group. It increases down the group because uh, positive ions are increased, ionic radius of group 2 ions are increased down the group, so there is less polarization between positive and negative ions. So that's why it is large amount of energy is required to break down. So that's why stability is increased down the group. Ammonium carbonate undergoes acid-base reaction with sodium hydroxide. We know that all ammonium salts are acidic salts. So when ammonium carbonate react with sodium hydroxide, ammonium ion become a proton donor, while OH ion, hydroxide ion in sodium hydroxide is proton acceptor. Figure 3.1 shows a sketch of some of the ionization energy of silicon. Complete the graph in figure 3.1 to show the third to sixth ionization energy of silicon. So this is and this is increased because shell is changed. Construct an equation to represent the second ionization energy of silicon. Second ionization energy. In second ionization energy, silicon exists in ionic form. This is gaseous ion to form silicon 2 positive plus electron. So next question is about 3.2 shows the boiling points of the simplest hydrides of the group 14 elements carbon to lead. So this is CH4, SiH4, this is germanium tetrahydride, tin tetrahydride, lead tetrahydride. Explain the trends in the boiling points of the group 14 hydrides. It is increased as we go down the group, carbon to lead. The melting point, boiling point of the compound is increased because CH4 to PbH4 have because CH4 to PbH4 have greater number of electrons. So when greater number of electrons, there will be stronger instantaneous ID forces are increased. So more energy is required to overcome the ID instantaneous dipole induced forces. Instantaneous, so ID means instantaneous dipole induced forces. Instantaneous dipole induced forces. Deduce the shape of silicon tetrahydride. This is tetrahedral shape because silicon like this H, so this is tetrahedral shape. Silicon readily reacts with elements of high electronegativity. Write an equation for the formation of silicon tetrachloride from its constituent elements Si plus Cl2 to form SiCl4. Describe what is observed when a small sample of silicon tetrachloride is added to water. When silicon tetrachloride is added to water, plus water, silica, SiO2 plus HCl is formed. So, the effervescence of the observation would be effervescence or misty fumes of HCl is formed. Silica is a white solid that melts above 1700 degrees centigrade. Silicon tetrachloride is a colorless liquid at room temperature. Explain the difference in the melting points of these two compounds with reference to the structure and bonding. Silica is giant macromolecule structure with many strong covalent bonds, while silicon SiCl4 is a simple molecule with weaker intermolecular forces. So it has it is liquid, while silica is a solid and melts at 1700 degrees centigrade. Uh, Tin forms an amphoteric oxide. Suggest the formula of the tin compound that forms when tin oxide react with H2SO4 in an acid-base reaction. We know that amphoteric oxides react with acid as well as base. So when tin react with the sulfuric acid, tin sulfate is formed. The formula is SnSO4 twice. Question number 4. A. Propanol is an important organic reagent. Figure 4.1 shows some reactions of propanol and its derivatives. Reaction 1 is a nucleophilic addition. Complete figure 4.2 to show the mechanism for the formation of A from propanol. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. So dipole is partial negative, partial positive, and compound is H3C CO CN CH3. This is H positive and this compound is formed. Explain why A does not show optical isomerism. So this is carbon, and carbon is this will become uh, this is chiral carbon, and chiral carbon is the carbon which is surrounded by four different groups, but this is not chiral carbon because this carbon is surrounded by two CH3, two methyl groups. So A does not show optical isomerism. It is not, this carbon is carbon in A is not surrounded by four or rather you can say, you can write down not bonded by four different groups. Suggest the reagents and condition for reaction 2. Reaction 2. This is reaction 2 and this is hydrolysis reaction. So the condition would be aqueous acid, dilute acid, sorry. This is hydrolysis, dilute acid. Any acid you can write down H2SO4 or HCl aqueous. Reaction 3 is a reduction reaction. Construct an equation to show represent reaction 3. Use hydrogen to represent one atom of hydrogen from the reducing agent. Reaction 3. So this is reaction 3. So this is construct an equations. This is propanol CH3CO CH3 plus hydrogen to form CH3 CH. This is secondary alcohol. This is propan to all. State what is observed in reaction 4. Reaction 4. So this is propanol and propanol when react with the 2,4-DNPH. So this is the test of carbonyl compound. So the products is this is mild. State what is observed in reaction 4. Reaction 4, red or red precipitates. Red PPT. Explain why failing reagent does not react with propanol. Because failing solution cannot oxidize ketone oxidized propanol or ketone. Compound A, B, and C can be distinguished using infrared spectrometry. Shows the infrared spectrum of one of the compounds. Compound A. So this is CH3. The 22 to 20, 2200 to 2250. This is the peak of nitrile. This peak is 22 basically start from here. 22 to 20 to 2250 is the peak of nitrile. Use table 1 4.1 to show this question. 28, 50 to 29, because all have CH bond. This is the CH bond, this is nitrile, and this is also CH, and this is OH bond. So CH bond alkane 2850 to 2950. 2850 to 2950. These are the CH bond. This is CH bond. This peak shows the CH bond. And 2200 to 250 is the CN bond. And hydroxyl bond is 25 3200 to 3600. So this is the hydroxyl bond. This is the OH bond. 3200 to 3600. This is showing AH bond, OH bond. Explain why absorption at 2850, 2950 are not useful to help to determine which of the compound A, B or C produces the infrared spectrum, figure 4.3. Use table 4.1 to answer this. All three have a CH bond, so that's why not useful to help determine which of the compounds A, B or C, because all have CH bond. This is CH3, this is CH3, this is CH3, this is CH3. Identify which of compounds A, B or C produces the infrared spectrum in figure 4.3. Explain your answer. Compound A, because the nitrile bond is 22, one peak to have, that is 2200 to 2250. So absorption at 2200 to 2250 indicates nitrile. So this is all. Hope you would understand this paper. If you understand this, if you like this video, please share it, like and subscribe the channel.